Alrighty, welcome back everybody. It's your main math man, Mr. Shane, coming to you live from Sun Academy. In this video, we're going to be talking about some polynomial functions and being able to identify where those zeros are at. So, on this first part, kind of looks like this. If it loads through. Alright, so we talked about in semester 1 class, we talked about being able to find those zeros of that quadratic function. Again, real simple. Anytime I have that equation, I can graph it out. So in this equation, it says we have f of x equals x squared minus 4x minus 21, and I'm looking for those x-intercepts, those roots, solutions, or zeros. And so what I can find is find where that curve hits the x-axis. So I'm going to say, all right, first one is going to be -3, and the second one is going to be +7. And it says enter the x-coordinate of the solution in the box using the smallest number first. So let's use the number to the furthest left. So I'm going to say -3 is going to be that first one, and +7 is going to be that second one. All right. So the key part or key idea is we're looking for where that curve hits the x-axis, or mainly where that curve, or where the points, where the points have the y value of 0. So that's what we're talking about. For our objective is we'll be able to identify the zeros of a polynomial from a graph using that language of math. So when we talk about zeros, roots, solutions, or x-intercepts, again, all four of those words are interchangeable, but it's just saying when f of x, being in that function, is set equal to 0, or just finding the functions, or finding the zeros of that function. Again, when f of x equals 0, it just means y equals 0, same idea. And we're just trying to find those x-intercepts. So a zero of a function is another name for those x-intercepts. So what we're saying is the zeros, the roots, solutions are all the same thing as x-intercepts. All right, so now for the next part, it says enter the zeros in the table below. So what I can do is I can write those ordered pairs. So I can find and say, okay, well, where are those ordered pairs at? Well, what I'm going to do is I just kind of trace along my curve and I say, hey, it hits at 4 different places. So I have one point here, another point at the origin, another point at 1, and another point at 2. But for each of those, I'm going to say it's going to be 0. So I have 4 zeros on this curve because it goes through the x-axis 4 times. So I'm going to say -3 is going to be the first one. Notice how it draws the point, and that matches up because it goes through the x-axis at that point, or at least touches the x-axis at the point. Then I have 0, 0, 1, 0, and 2, 0. So notice how for each of those points it kind of graphs them out for you, but you can compare as well to make sure those are all the correct points. But as long as they have a y value of 0, you know you're doing good. Then after it, it says enter the x-coordinate of the zeros from the graph from the left to right in the boxes. So 1 0 per box. So I'm going to say, okay, well, I have 4 boxes, which means I have 4 points where that curve hits the x-axis. So I'm going to say my 3 x-intercepts, or my 4 of these, actually. I'm going to say -3, I have -2, I have +1, and I have +2. And it should have that little check to show that you're correct at the bottom. But all I'm just listing off is just where those x-intercepts are. All right. So now it says, know some wonder. It says, look at the root on the left and the root on the right. So I'm talking about where we have an x-intercept on these 2 points. What do you notice about the difference between those 2 roots? So what we could say, I could say something like this. I could say I notice that the root at x equals -3 goes through the x-axis, comma, but the root at x equals +2, let's say bounces off of the x-axis. What I mean by that is this. I'm just saying that if you look at, this curve, again, I definitely have two roots at these 2 points, but they look very different from each other. So at -3, the curve of my function, that green or bluish curve, it goes through the x-axis, it passes through, where the x-intercept at 2, 0 just bounces off the graph. So it's almost like a bouncy ball where it, kind of does not pass through the x-axis. So it goes through that point 2, 0, but it does not, pass through that x-axis, I should say. This still means, though, that it is a root because I have anywhere where it has a point at, where y value equals 0, it is still a root. So let's talk about what that's going to be labeled as. So we're going to call that a double root. So anytime that it bounces off the graph like this is considered a double root, and it's shown like this. It's shown, normally we would have, okay, I have x minus 2 because I have positive 2 at my point. I have x plus 3 because I have x equals -3 at this point. So I'll always take the opposite of whatever those x values are on your graph, and when you get the equation, they should be opposite from the points in the graph. But I need to say that, hey, I have to have an exponent 2 to show that it has another curve at that point. So it says the root on the right seems to just touch or even bounce off of the x-intercept. This is called a double root. So the equation of this graph is f of x equals x minus 2 in parentheses squared, and then times x plus 3 in parentheses. So it says that x minus 2 squared is what is causing the root to bounce off of the x-axis. This is called a double root and is counted as 2 roots. So in total, if I was to count the total number of roots for this, I would say 3 because I'm counting, I have 1 here because this is a single root, and I count this one twice because it is a double root. So in total, this equation or this graph has 3 total roots. So in this picture, same idea. I can say I have a single root at 0, 0 and a double root at 3, 0, and the total number of roots would be 3. So let's say exactly that. So I have, all right, let's say this graph has, or let's say this curve has a single root or single x-intercept at x equals 0 and a double root at x equals 3, we add the number of roots together to get a total of 3 roots. So even though I see it hit the x-intercept twice, I have to make sure I count, if it has a double root or a single root, I have to make sure I count those carefully. Again, make sure you're signed in so that way it saves your work. Make sure you hit that submit button. All right. So on this one, this how many roots does this one have? Well, this is a quadratic function because it has that U shape. So that's going to tell me I have 2 roots. And real simply, I can say this. I can say I noticed that the curve has a single root at, let's say, -3. Let me double check. Yeah, I'll say at x equals -3. Let me rephrase this actually. Let's say it has single roots, plural, at x equals -3 and x equals +2. Sweet. Moving on. How many roots does this one have? So real complex. Got a bunch of points here. So let's make sure we count. So we have 1 x-intercept, 2 x-intercept, 3, and 4. So we have 4 places where it hits the x-axis. But at 2 of those places, it has a double root. So I'm going to say it's going to be 6 total. So I have 1, 2, 3, 4, 5, 6. So this curve has let's say it has 2 single roots at x equals -3 and x equals +2. And let's say also this curve has two double roots, and let's say x equals -2 and x equals +1. Those are going to be my two places where I have double roots because it bounces off the graph. Notice how it doesn't go through the x-axis at that point, but it does go through that specific point. So I'm going to call those double roots. All right, last two here. This is how many roots does this one have. This one doesn't touch the x-axis, so we're going to say 0. So since this curve does not hit the x-axis, comma, or let's say this curve does not have any x-intercepts. All right. And then lastly, for that x ticket, try to sketch an equation on the sketch pad with exactly 2 regular roots, meaning singular roots, and 1 double root. So this is what I need. I want you guys to, so your turn is going to be 2 single roots and 1 double root. So I need to just draw a curve that goes through those points. So let's say something like this. Let's go 1, 2 single roots, and then let's do a double root like that. I'm going to draw my arrows to show it keeps going. Again, it doesn't have to be exactly that. Again, I can be flipped. I could say let's do it like this. Let's say, what if I went the other way? I have a double. Let's try that again. Let's have a double root here. It goes down, goes through, and goes through. So any way you draw it, again, you have several options of how you want to do it. Maybe you have a single root and then a double root, then a single root, or you can have a couple different options. But as long as you have where one point it bounces off the graph, and then 2 other points it hits the x-axis or goes through the x-axis, then you'll be good. So make sure you check with me. Make sure you ask questions. And as always, super slam that subscribe button.